Hello, everyone, and welcome to today's Thorogood Associates hosted webinar, Managing Multi-Cloud Data Strategies at Enterprise Organizations. My name is Alaistair Jones, and I'm a data and AI consultant based out of our London office with experience working with clients from our US, Singapore, and now our UK offices. I am joined by my colleague, Fernando Takeshi, who is also a data and AI consultant with experience delivering strategies and solutions for clients from our Sao Paulo, Brazil office. So I'm going to start today's webinar by briefly explaining who Thorogood is and why we're well positioned to explore this topic for those less familiar with us. We'll then discuss a brief history of cloud computing and how the cloud has impacted data and AI. We'll define multi-cloud data strategies and review how many enterprise organizations are or are planning to be multi-cloud in nature. We'll explore the important considerations when operating in a multi-cloud world and discuss specific technical considerations as they pertain to the realm of data and AI. So Thorogood is a specialist data and AI consultancy with offices in the US, Brazil, the UK, India, and Singapore. We offer a range of services within the niche of data and AI, from tool selections and roadmaps to training, platform support, and adoption initiatives. The bulk of what we do is application design and development. As a consultancy, we're customer focused, and we're also independent, meaning that we partner and work with several of the leading vendors and platforms in our space. And we think this independence makes us uniquely well placed to discuss multi-cloud data strategies with you all today. We have long-standing partnerships with several of the leading cloud vendors in Microsoft Azure, Amazon Web Services, and Google Cloud, and cloud data platforms in Anaplan, Databricks, and Tableau. We deliver initiatives for clients on and across these various cloud offerings as makes most sense for that client's needs. And in terms of those clients that we work with, well, we work with several blue chip industry leading firms. Primarily, our work tends to be with companies operating in the consumer goods, insurance, banking, and healthcare industries. We find these sectors tend to be particularly data rich, but we're not at all limited to working with organizations in these industries. And we do often branch out, as evidenced by some of the names on the screen. So I'm going to start today's content by discussing cloud computing, introducing cloud computing, sharing its origins, its history, and then beginning to discuss its particular relevance to data and AI. So the late decorated former Stanford professor, John McCarthy, a visionary computer scientist who was actually the first to coin the term artificial intelligence, suggested in 1961 that computing would one day be sold as a utility. And this is one of the core concepts that defines the cloud today. We've seen the advent of massive technology companies such as Microsoft and Amazon doing just this. Another key to making cloud computing work is the ability for multiple users in different locations to share the same computer resource, which is referred to as virtualization. The third core concept and prerequisite for enabling cloud computing is accessing these shared resources via networking. Now, if we step back and take a look at the history of cloud computing since John McCarthy's prescient quote in the early 1960s, we saw several decades of progress in terms of computing, from the invention of the personal computers between the 1960s and 1980s, through to the 1990s, which marked the widespread adoption of personal computers, as well as, very importantly, the beginning of the internet age. Amazon Web Services became a cloud computing vendor when they created an offering to host other retailer websites in 2002. AWS, or Amazon Web Service, broadened their offering with a platform that included S3 cloud storage in 2006, and Microsoft and Google entered the fray in 2008, and all of these firms started to offer their own proprietary database services that mimicked the software available for sale to be deployed on on-premises servers. The early 2010s saw the proliferation of cloud-native platforms from independent companies, the likes of Databricks, Snowflake, and Tableau Online, offering customers more compelling choices. That led to a double in cloud spend during the latter part of the 2010s, from approximately $35 billion per year to $70 billion per year in just 5 years. Now, in the first third of the 2020s, we're beginning to see the increased prevalence of multi-cloud strategies for a variety of reasons that we'll explore today. But before we do that, when considering how we define cloud computing, it's probably worthwhile to turn to one of the commercial pioneers and long-standing market leaders in the space, Amazon Web Services. They describe cloud computing as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing instead of buying, owning, and maintaining physical data centers and servers. You can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider. So fundamentally, The cloud enables companies to move from large fixed upfront investment with a commitment to recurring costs and staffing to manage these investments to minimal initial investments, but rather paying for what they need and use, allowing them the ability to scale up or scale down as they feel makes most sense. In accounting terms, firms are trading CapEx for OpEx spend with the cloud. It's worth mentioning that there are various discrete types of cloud services, from infrastructure as a service, or IaaS, which is most akin to on-premise server management in terms of what the customer retains and has to handle. So the handling of OS applications, middleware, data runtime, and more, to platform as a service, or PaaS, which entails less management by the customer still, to SaaS, or software as a service, whereby almost all aspects of managing and maintaining the application are handled by the vendor on behalf of the customer. So finally, how has the cloud transformed the data and AI landscape? Well, it's enabled a never before seen level of agility and responsiveness, with data functions able to create and adapt faster than ever before. It's engendered operational resilience, with large technology organizations backing these services with highly advanced data centers. It promotes innovation, as organizations are able to tap into best-in-class services available on clouds readily and quickly. It fosters experimentation, as trialing and provisioning cloud services is simpler than ever before. It reduces dependence on IT. This is enabled by the tech vendors providing the majority of the support and maintenance entailed. It allows flexibility for quick analysis on a broader array of data than ever possible before. And ultimately and critically, it enables DevOps, which is the principle of an organization efficiently maintaining, but also enhancing and developing their solutions simultaneously in a well-managed and governed way. So now I'm going to hand it over to my colleague Fernando, who will focus on the application of cloud computing to data initiatives specifically. Over to you, Fernando.
Thanks, Alaistair. As Alaistair introduced me earlier, I'm Fernando. I'm also a data and AI consultant here at Thorogood. And I'll pick up from here and share some thoughts on what are multi-cloud strategies. In the context of the cloud and its benefits in mind, as Alaistair enumerated, what really is a multi-cloud strategy? This can be used as a buzz term in many contexts, and even without intention to do so. The enterprise may have multiple cloud services or providers in use. And that is why, to have a multi-cloud strategy, the movement to use cloud services from multiple public cloud providers for the same general class of IT solutions or workloads should be deliberate, or in other words, intentional. Also, it is important to highlight that when we are referring to an organization being multi-cloud, we are referring to them using infrastructure as a service or platform as a service across clouds, and not software as a service, which are usually completely managed by the vendor, as Alaistair had mentioned a little bit before. The use of the word deliberate is key here, as many organizations become accidentally multi-cloud through inadequate governance, M&A, and etc., rather than intentionally adopting a multi-cloud strategy. And being multi-cloud increases management and governance challenges, increases the complexity and cost of IT, and demands greater skills. However, a well-governed multi-cloud strategy can improve an organization's success and increase access to a breadth of technology choices and innovative cutting-edge capabilities. And that is why we see interesting numbers from a recent study by Gartner, which reported that roughly 92% of enterprises are theorizing a multi-cloud strategy. So we mentioned about both the incidental and deliberate use of multi-cloud. And I wanted to bring up some real-world examples from our experience as an organization in working with some of the largest enterprises in the world. And what are the different reasons that have been for an organization to become a multi-cloud one? To make things clearer, let's put some reasons and examples on a spectrum. First example represents a capability multi-cloud strategy in a biopharmaceutical company we work with, which deliberately has integration of best-in-class tools for various cloud purposes. Some of their operations are done in AWS, others in Azure. It all hinges just on service quality. This one certainly lies towards the deliberate side of the spectrum. Next, we have seen an acquisition done by one of our consumer goods manufacturer customers, which ultimately resulted in the buyer company cloud sitting alongside the acquired company cloud. This example surely lies towards the other end of the spectrum, being a very incidental situation. Also, in a CPG firm, we have experienced the need to use different cloud services to ensure compliance with retailer data standards. Regulatory reasons such as data residency rules, or the government-mandated data security has led enterprises to adopt a multi-cloud strategy. This example can be classified here as an even more deliberate reason, since the company doesn't even have the choice. The last one I would like to mention refers to a proliferation type of incident or strategy, where due to the lack of alignment between regions and lines of business due to their scale, a leading insurance broker operated with a multi-cloud setup. Smaller teams had no central coordination from IT, causing the proliferation to differentiate cloud providers across different sectors of the firm. This example is a case of a lack of thought about a company's cloud organizations, and therefore lies in an incident or extreme end. So let's quickly review the types of multi-cloud reasons we have just seen. On one end sits the example we just discussed, with proliferations and lack of company organization. Following that, M&A operations, still in a very incidental range. Up on the deliberate stage, showing data maturity from a company, we discussed the capability example, where a company chooses different clouds based on what each of them can offer best. Lastly, a mandatory regulation multi-cloud strategy, where the company is forced to use different clouds. Something we also frequently see that I have also added here are commercial examples as well, where a company purposely has different cloud providers based on cost tracking metrics. That is what we'd call a commercial multi-cloud strategy. Now that we know that to be intentionally multi-cloud, a firm requires data maturity, let's now discuss a few reasons for why these data mature organizations may intentionally walk that path. First one would be to increase productivity. Using top resources from various cloud vendors allows it to be more productive. And as I mentioned earlier on the capability example, one vendor could efficiently handle your large data transfers, while the other could excel, for example, in other critical use cases that provide a distinct competitive advantage. Secondly, apart from productivity, working with different cloud providers offers more flexibility. IT teams could face unique challenges when deploying certain apps and may need to use AWS to store data or Azure for data processing. Having access to multiple clouds makes things possible. Further, as we have mentioned earlier, companies can move their workloads between different cloud applications and take advantage of dynamic pricing and thus cut costs. And this is related to our next point, that having a multi-cloud strategy helps organizations avoid being locked in or dependent on a vendor and its protocols, proprietary systems, pricing. A strong reason to explore a multi-cloud strategy is that if your primary cloud fails, you can move data, workflows, and systems to a backup cloud. A multi-cloud strategy is a fail-safe solution that ensures that your mission-critical apps are always available. And next, working with multiple cloud vendors allows companies to store data in data centers closest to their customers. The proximity to end users reduces latency and improves the response times of cloud services. With the proliferation and wide adoption of cloud worldwide, more and more data centers are popping up for the new major cloud vendors. But for now, this is still a relevant and strong reason. And finally, as we have hinted to earlier, data privacy and data governance regulations, such as the General Data Protection Regulation, or GDPR, often require that sensitive data be held in specific jurisdictions. A multi-cloud strategy provides companies with different options on where to store their data. And in summary, all the reasons stated here offer a compelling case for why an organization should consider having a multi-cloud strategy. Because if done right, it enables organizations to speed up time to market and spend less and innovate freely. But there are also challenges as well to be aware of. As a result of becoming multi-cloud, an organization architecture complexity may increase manifold. If the usage of multiple clouds and services is not done in a governed and consistent manner, the overhead of maintaining our cloud footprint can become a nightmare. Secondly, being multi-cloud demands extra agility from organizations and its IT teams. A multi-cloud strategy may offer more flexibility, but managing multiple cloud applications and shifting between them requires agility and precision. Thirdly, managing and moving data in various clouds require that organizations defend a wider attack surface and deal with more security threats. It's also key that an organization establishes its security protocols in advance of expanding their footprint into multiple clouds. Retrospective fixes over a wide landscape could leave vulnerable attack points, which have the potential to significantly affect an organization's business. Regulations such as the GDPR hold both users and providers of cloud services accountable for privacy and security breaches, and it is important that mechanisms are set in place to avoid them from the outset. And lastly, a multi-cloud strategy means organizations are responsible for data governance in multiple clouds. Tracking the flow of data from source to usage could pose a challenge, especially for applications that span across clouds. Enabling access and ensuring data discoverability across the landscape of multiple clouds could prove to be difficult as well. We will pick up on this particularly in a few minutes in the technical considerations. So if these are some of the challenges, let's also discuss some key success factors to overcome some of these and cut some edges of the difficulties of multi-cloud. I would start off by saying that knowing the why of multi-cloud is important. Organizations must keep their objectives top of mind, whether it is modernization, cost savings, reducing vendor lock-in, or eliminating on-premise IT infrastructure. This should also include buy-in from all stakeholders, including executives. Knowing the why helps organizations retain focus and judge new developments options critically, enabling the objective of choosing that which fits their particular needs. Also, keeping an eye on costs. I keep coming back with that example on commercial types. Cloud platforms are different. Without an abstraction layer or a way to create consistent operations, security and governance costs can grow with the addition of each cloud. And also, plan for the needed skills. Multi-cloud adds complexity, and perhaps 2 to 3 times more complex than utilizing a traditional single-source cloud environment. Although management tools can mitigate some of this complexity, new skills will be required to manage a multi-cloud environment and to take advantage of the benefits of cloud-native application strategies. Whether these skills come from training existing teams, hiring outside, or leveraging partners, they will be required to get a multi-cloud strategy off the ground. And also to measure progress. Organization leaders will want to determine if a multi-cloud strategy is achieving its stated goals. Look for ways to measure the payback of this approach through, for example, return on investment or ROI, demonstrating reduced costs of ownership for IT over a given time frame, or most importantly, accounting for the business benefits that have been made possible by being multi-cloud. Document and report on outcomes, and share the reports with stakeholders to grow confidence in the strategy enterprise-wide. I'll now hand it back over to Alaistair, who will present some technical considerations on some of the strategies we have seen.
Thanks, Fernando. So, having looked at some of those kind of more commercial considerations, I think it would be useful to hone in on some of the technical considerations involved in being a multi-cloud organization. And I want to talk about those specifically as they pertain to data and AI. So, at the outset, I'd mentioned 3 particular ingredients of cloud computing, and those are utility, networking, and virtualization. These have effectively been made available by the major cloud providers, Amazon Web Services, Microsoft Azure, and Google Cloud, in a relatively commoditized way with pretty minor differences between the offerings. Now, when choosing services which utilize that base kind of cloud layer, it's important to be conscious of a few considerations as organizations are posed with different fundamental choices. They could use a cloud vendor's proprietary service. Those tend to be specific to that cloud. And those services were often heavily utilized by the early adopters of the cloud, just based on them being available first in many cases. There are platform as a service or software as a service offerings that they could seek to use that can be available across cloud platforms, such as Databricks, Snowflake, or Informatica. And these are options that are pretty popular today and increasingly so. Or an organization could use something as a basis, like Apache Spark, which is truly open source and allows for easy portability across cloud platforms, though it does entail a high degree of customization and thus kind of technical ability and capability within the firm. We would generally advocate for organizations to consider using languages, tools, and offerings that are more open in nature where possible. The more organizations are employing a multi-cloud strategy or intending to move towards a multi-cloud setup can move away from using technology-specific features which restrict portability to something that's open enough to allow quick pivots as and when needed, the easier it will be to get the most out of the various clouds that are in use. As we mentioned earlier, there are always considerations and reasons that exist for specific features or tools that are proprietary or only exist within a specific cloud to be chosen, and that is fine. The idea is generally to have that to be the exception rather than the default rule in a multi-cloud world. And really supplementing that point, maintaining data in open formats allows for easy replicability if required across cloud platforms and provides an organization with maximum optionality to utilize the services they like at scale. Where data is required to be visualized using SQL and in relational tables, well, there are now abstraction layers that provide functionality over data lakes like Databricks SQL, and thus the storage of data in databases, which was the traditional option and one that could make portability potentially difficult, now has a viable alternative in data lakes and lake houses. To support the portability that tools which run on multi-cloud platforms and something like Spark provides in conjunction with open data formats, an organization must have expertise in DevOps, mentioned earlier, achieving consistent deployment patterns, proven and dependable ways to manage the movement of data, and replicating functionality where needed. And doing all of this in a secure manner is fundamental to a successful data and AI multi-cloud strategy. Finally, as mentioned earlier, the need for governance, which spans multiple data platforms, although a challenge, is slowly becoming possible through tooling like Azure Purview, which is Azure's data governance offering and can connect to all data assets in the Azure world and on your on-premise setup, but is now also able to work with data stored in the data lake within AWS and BigQuery within Google Cloud. And this makes having a bird's eye view of data movement across a multi-cloud landscape a possibility. There are several more aspects to consider, but hopefully this list serves as a useful primer for those of you who are thinking about a multi-cloud setup through the lens of data and AI. And of course, we would be happy to help with that thinking and broaden it further. Our independence as a firm, our strong partnership with the leading cloud vendors and platforms, and our experience working with and defining multi-cloud setups for some of the leading organizations in the world holds us in good stead to have a conversation with you and tailor all of these considerations and more to your specific needs. With that said, I'd like to thank you for your time today. Mine and Fernando's contact credentials are on the screen. We'd be more than happy to pick up with you on this topic via LinkedIn or by email. Feel free to reach out to us. Thank you and goodbye.